So if your function is tons, the derivative will be tons divided by a time unit. Could be seconds, could be hours, could be minutes, could be whatever unit of time there is. Now, they might ask you, when does the particle change directions? What does change directions mean? It was going right, and now it's going to be going left, for example. Or it was going left, now it's going to be going right. Or it was going up, now it's going to go down. Or it was going down, now it's going to go up. Whenever the object changes its direction, the velocity of the object becomes zero. Velocity is zero, but the acceleration is not zero. Not zero. Okay? You make your velocity equal to zero. Now, if you were given a position equation, how would you make it into a velocity equation? You would differentiate. If you're given a velocity equation, how would you make it into acceleration equation? You would also differentiate. Wow. This is crazy, right? Crazy easy. Now, when is the particle slowing down? Guess where this came up? Princeton Review, Chapter 6, Example 3. The particle slows down, and also AP, when the sign of the velocity and the sign of the acceleration are not the same. One is positive, one is negative. Okay? So yeah. Now, when is the particle speeding up? The velocity and acceleration have the same sign, either both positive or both negative.
Sorry, what did you say?
Slowing down. Velocity and acceleration have the opposite signs of each other. Speeding up, they must have the same sign as each other. Speeding up just means increasing in speed. How could you find distance between 2 points? You first find the derivative of x, which basically means you find the equation of v, make it 0, and find the time.
Isn't that physics? It's
Semi?
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 That's fully.
Semi? Fully? It doesn't matter. Let's jump to the book. Let's look at example 1. It says, if the position of the particle is given by xt is equal to t cubed minus 11t squared plus 24t, find the velocity and the acceleration. If you want to go from distance to velocity, what do? Differentiate the heck out of it. So vt is equal to,
Differentiate the differentiation from double.
yeah, so vt is equal 3t squared minus 22t plus 24, while a is equal to 6t minus 22. Now simply replace t as 5 in both of them, and that's how it works. Yeah. Let me recap how to differentiate, but please listen this time. So to go from x of t to v of t, to go from position to velocity, you must differentiate. What is the derivative of t cubed? You answer. What happens to the 3? Goes down. Then what happens to the power? Thank you. Minus. 11 stays the same. T squared. The 2 does what? Goes down. How about the power? What's 2 minus 1? 1. So I write no power because no power means a 1. Plus 24 stays the same. And whenever we differentiate a letter with a power of 1, the letter disappears. Now you're going to have Vt is equal to 3t squared minus 22t plus 24. Let's now find the acceleration. The 3 stays where it is. The power 2 goes down. And now the power is going to be 2 minus 1, which is just a 1t. Minus 22, letter disappears upon differentiation. And the number 24 disappears if it's alone. And now 3 times 2 just equals to 6. And that's how you differentiate. Now let's give you some new information. If the velocity is negative, the particle's moving left. The velocity is positive, it's moving right. The velocity and acceleration have the same signs. The speed is increasing. Velocity and acceleration have opposite signs. The speed is decreasing. Velocity is 0. Acceleration is not 0. The particle is changing its direction. Let's do example 2. Find the point where the particle changes direction, which basically means the point where the velocity is 0, but the acceleration is not 0. So now, what do? You should turn x into v. You must equalize your v to 0 to find the times when the velocity is 0, and then we'll talk. So now what do? Turn x to v by differentiation. Start. Let's find the velocity. Should I show how to differentiate, or you guys are good now at differentiation? 3t squared minus 24t plus 36. Equalize that velocity to 0. Now divide everything by 3. You will get t squared minus at plus 12 is equal 0. What follows now is simple factoring, which you guys learned in school.
Yes.
So go ahead. What do I put? T here and t here. The signs are on you and the numbers are on you. Simple factoring. All right, so guys, we're going to have a -6 and a -2. We agree? So t is going to be either 6 or 2. Now, we found the times when the velocity is 0. But the question is, will the acceleration be not 0 at those times? So how do we know now? We find the acceleration equation, we plug in those times, and we see if the acceleration is going to be 0 or not. Do you get it? Right now we satisfied the first part. The velocity is 0 at those 2 times. But the question is the acceleration not 0? So we're going to find the acceleration, we're going to plug in those times, and we're going to find out if it's true or not.
2, it's
1 second. What's the acceleration equation based on this equation of velocity? 6t minus 24. Now plug in the 2 and plug in the 6 and find out if you will get 0 or not.
Both of them I didn't get to.
6 times 2 is 12. 12 minus 24 is negative 12. 6 times 6 is 36, minus 24 is 12. So, we satisfied both conditions. The velocity is 0, acceleration is not 0, the particle is now changing directions at 2 times. In the time of 2 and the time of 6. We answered the question with your help. Okay, for part B of the question, it says how far does the particle travel between the 8th and 10th seconds? So the particle travels a certain distance between the 8th and 10th seconds, and we're supposed to be finding out what that distance is exactly. So, to do so, let me show you the two scenarios we have to adhere to. So we got two scenarios here. The scenario that the velocity is 0 at the time in the time interval provided, and we must be following this equation, or the velocity is 0 at the time that is not in the time interval provided. Let me show you what that means. Now, if you recall back in part A, we saw that the velocity was equal to 0 at 2 times, 2 and also a 6, right? And so our velocity is 0 at the time, which is not in the time interval. Because what's the time interval? Between 8 and 10. Our velocity is 0 at 2 and 6. So if that's the case, it basically means that we have to use this equation, which is the simpler version of things. Now, let me show you how that's going to be done with this equation. So we will just say x at the time of 10 minus x at the time of 8. That means you must go back and you must replace every single time here with a 10, apply the equation, minus replace every single time here with an 8, and apply the equation. Now, assuming that a calculator is allowed, I'll come here and I will write my equation. So I'm going to be writing x cubed minus 12x squared plus 36x plus 18. And now I'm going to be clicking on this sign here, or sorry, this one here. And I'll be putting a table. And I'm going to ask it for when the x is 10, how much is my y? So assuming that a calculator is allowed, I'll come and put my equation here. I'll put x cubed minus 12x squared plus 36x plus 18. I'll come here on the sign and I'll be putting a table. And I'll ask it for the x of 10. It's 178, and the x of 8, which is 50. So now when x is 10 minus x of 8, that basically means 178 minus 50, and I'll be getting 128 as my answer. Now let's go on to part C, where it says how far does the particle travel between the 1st and 5th second. We must be using now this one here. Why? Because our velocity was 0 at the time of 2 and the time of 6. And now our interval is between 1st and 5th. So we're going to go from 1st, then to a time of 2 where the velocity is 0, and then all the way to the 5th. So now we should do the following. We should do x of 2 minus x of 1, absolute value, plus absolute value again, x of 5 minus x of 2. Okay? And now I can use Desmos for the results. So now in Desmos, I'll be asking it for the x of 1, for the x of 2, and also for the x of 5. And I'm going to say we have x of 2 minus x of 1 in the absolute value, plus the absolute value of x of 5 minus the x of 2. So, x of 2 is equal to a 50 minus 1, which is 43, within the absolute value, plus x of 5, which is 23, minus x of 2, which is 50, absolute value. We'll get 7 plus 27, which is equal to a 34.